All right, here's our video today. Identifying compounds. In other words, we're going to be naming substances. So let me get my pen. Start with that color. So the rules for naming chemical compounds, for example, is called nomenclature. So let's write that down here. Nomenclature. Just a fancy word, nomenclature, for the rules. Nomenclature, the rules for naming compounds. And we'll have a few. We'll have one. You should know the prefix mono. Mono means one. So when you have, let's say, I'll write something here and you can try to figure out what this means. Monatomic. What do you think that means? Well, in this case, it's going to be an ion that contains only one atom. So we should know what ions are also, and so forth. So let's get a clean page and get to town. So let's start with an ion. We should know what an ion is. So when we think of an ion is either going to have two things. It's going to be either has, or either, however you want to pronounce it, either has more electrons than protons, or, forgot the or vice versa, right? Has more protons than electrons. And we know that electrons have a negative charge and protons have a positive charge. So when an ion has more electrons, it's negatively charged. And if it has more protons, it's positively charged. So there's names for that. If you have a positive charge, see the plus sign, a positive charge, you're called a cation. Think of a cat. Some students think of cats having a positive attitude. Cations have a positive charge. For example, sodium. So sodium ion, remember we're talking about ions, you'll see that plus sign up there saying it's a positively charged sodium ion. So this is a sodium ion. And please do not say salt, because sodium has to combine with other substances, other halogens, to create salt. So by itself, it's a metal, it's a soft metal. By itself, it's an element, and it could also be an ion, as you see here, which we need. It's very important in our body to have these sodium ions. Now, if it's a negative charge, of course, we'll have the symbol like that, negative charge, and they're called anions. So we have our cations that are positive, our anions. For example, chlorine. Very important for muscle contractions in the body. So chlorine, you'll just have the Cl with the little negative sign on it. And of course, when sodium and chlorine combine, you get sodium chloride. And all these ones I named, this one, sodium ion and the chlorine ion, they're monatomic, because it's one, monatomic. I'll write it again. Monatomic. Alright. So I'll keep that up for a minute. Rewind if you have to. Alright, I'll clear that out. Clear it all out. And maybe I'll keep it yellow. So let's look at something else. Let's look at sulfur. Why not? So sulfur has a symbol S. Pretty ingenious. Sometimes you can see not just a negative sign, but you can see a number before it. So let's say, let me rewrite that so you can have that 2, the negative sign. Now, of course, we know it's an ion because it has a negative sign. But that superscript, that thing that looks like an exponent, a power, that's just saying, since we know it's a negative ion, so it's going to have 2 extra electrons. That's all that means. All that means up there. And if let's take phosphorus. Now phosphorus, again, ingenious to put the P. What do you think that means? We know it's a negative ion, and it has 3 extra electrons. Now you could have sulfur that has 1 extra, and you can have phosphorus that has 2 extra, but just showing you how this nomenclature works. Again, anions are what? Negative. Excellent. Let's move on. Alright, clear it out again. Clear it all. Make sure the pen's working again. So, when you're talking anions, we'll just talk about them. Again, these are the negative charged. They're going to have certain endings that we can identify them as anions. So chlorine, for example, chlorine in its neutral form is chlorine. And what I mean by the neutral, I mean it's not an ion, right? It just has the same amount of electrons and the same amount of protons. When it becomes an ion, though, there's certain endings. You can have the IDE ending. So it could be chloride. And that just means it's an ion, chloride. And again, it's monatomic. But if it was combining with other things, you might see ITE, ite, or ATE. So all ITE and ATE means is, and both of these, is they have oxygen. They're combined with oxygen. That's all it means. So anything with an 8 on it at the end means it has more oxygen. So for example, we'll write sulfate. So we talked about sulfur before. So sulfate has sulfur and it has oxygen. It has actually 4 oxygen. You see this subscript right here saying it has 4 oxygens molecules. And then you could see up here where it says 3 with a negative, it means it has 3 extra electrons and it's negative. So that's sulfate. All right, go back if you need to. So remember, if you see an 8 at the end in the over here, just think of the 8 more. Sulfate has more oxygen, higher concentration of oxygen than sulfite. And let's clear this out again. Clear it out. You can always go back. So you're also going to hear the word oxide. Well, that's just oxygen. That's an ion. So if you see this, what do you think that means? Well, you know it's an ion. You know it's negative. So it just has 3 extra electrons. That's what that would mean if you see this. Now let's talk about transition metals. So like iron and so forth. So if we had iron, in iron you'll see it as, you could see something like this. Fe is the symbol for iron. You see there's 2 and a plus. What do you think that means? Well, that means that it is a positive ion, which means it's a cation, and it has 2 extra protons this time. And you can write it also, they use Roman numerals, so they'll say iron, in parentheses, 2, meaning 2 extra protons. And if you see this, what does that mean? 3 extra, right? So you would write what? 3. Those are the transition metals. Now, transition metals can form ionic bonds. And you should know with ionic bonds, they're not sharing. Like, for example, with water, when you have oxygen and hydrogen, that's a covalent bond. They share, which oxygen shares a little more. But ionic bonding, they're not sharing, right? So when sodium and chlorine combine, that's ionic bond. Chlorine needs that extra electron to be complete, where sodium's trying to get rid of it. And you should know something about ionic and covalent bonds. I have videos on that if you want to go back. So let me clear this out, and we'll talk about how transition metals can form ionic bonds also. So let's look at one. Let's look at, that's copper. That's a metal, transition metal, and this chlorine. So this will become copper chloride. See that IDE there? And you could write it also as copper, right, and parentheses 1 in the Roman numeral, and then chloride. And you can also see it as copper chloride, and to balance it out, you'll have that 2 there. What do you think this means? What if I put, that's cobalt. So that you would write cobalt. And what should be the Roman numeral? 3. Exactly. Let's clear this out. Okay, let's change the background there, a little popsicle color. Green popsicle, if you remember those. And maybe we'll just, who knows what we'll use. We'll use that. So I'm going to talk about the crisscross rule. Crisscross applesauce, right? The crisscross rule. So let's say we had aluminum, or aluminium if you're in England. So here we know it's a positive cation, it has 3 extra protons. And let's say we also had oxygen, so 2 extra electrons, and it's negative. We can crisscross them to balance the equation. So then aluminum, we need 2 extra aluminums and then 3 extra oxygen. We're just taking the numbers in the absolute value, not the negatives or positives, just bringing them over, crisscrossing them over, and you'll get aluminum oxide. Just take the numbers and give them to the other element. So let's try one. If we have room, make a box over here. What if I had magnesium, and you saw that, magnesium, you saw 2 extra protons, it's a cation, and then sulfur, and you saw a 2 there, you know that's an ion. So if you crisscross the numbers, just the numbers, absolute value, we'll know we're going to have magnesium. Okay, we have magnesium, and then sulfide, magnesium sulfide. What would the numbers be, though? What would the numbers be? Well, since they both have 2, we're just going to say magnesium, subscript 2, sulfur with a subscript 2. Let's do a few more. Clear that out. Go back again if you need to. Let's say we had calcium, put calcium chloride. So here's calcium, has 2 plus. It's a cation, 2 extra protons. Chlorine, let's say we have a negative 1. We're going to crisscross the numbers. We always start with first, so we're going to have calcium. You don't have to put a 1 there, but if you want, put the 1 there. And the chlorine will be the 2. So it's just calcium chloride. Of course, you can put the 1 if you wish. Alright, that's part 1. We'll talk about more compounds and naming them in our next video.